Welcome back, welcome back, welcome back to Algebra 1, Chapter 12, Section 3 in this book. So last time I told you that we were talking about radical equations. I said it sounds like something from the 80s, radical dude. And then I thought, do I remember anybody in the 80s actually saying radical dude? And I do. It was my nephew Philip, who was really into the Ninja Turtles. I think those Ninja Turtles used to go, radical dude, let's eat some pizza. I don't know though. I used to watch He-Man with him, and I used to watch the Smurfs with my niece Becca, but I don't remember exactly what those turtles used to say. Alright, anyway, it sounds cooler and like maybe it's from the 80s, but it's not. A radical equation is one that has the radical sign in it. And we're going to solve them now. And how are we going to solve them? By asking ourselves a series of questions that says, why is x not alone, and doing the opposite? What we've been doing the whole year, right? Okay, so why is x not alone? It's got a radical sign and a -7. We work from what's further away to what's closer, so we're going to get rid of the -7 first. What's the opposite of -7? +7. What we do to one side, we do to the other. Those cancel out. And we get, we bring down what we didn't mess with, the square root of x equals 7. Now, why is x not alone? Because of the square root sign. What's the opposite of square root? Squaring. What we do to one side, we do to the other. And x squared frees it from the radical. And now it's just an x. And what is 7 squared? 49. Now, remember I told you some of this at the end of the book, I just want you to see and kind of get. Others I want you to be able to do. I want you to be able to do this. This is not too hard. You can do this. You are great at solving equations. Now, you're going to be fine. Okay, let's try this one. Why is x not alone? Well, it's got a 2 and a -3 and a radical sign and a +3 and a 4. So we're going to work from the outside in and get rid of the +3 first. What's the opposite of +3? -3. What we do to one side, we do to the other. Bring down what we didn't mess with. 4 minus 3 is 1. Why is x not alone? The 2, the 3, and the radical. What is considered the most outside is the radical. So we're going to do the opposite and square both sides. The squaring gets rid of the radical. So you have 2x minus 3, 1 squared is 1. Now we just solve it. What's the opposite of, once again, working from what's further away to what's closer. The opposite of -3 is +3. What we do to one side, we do to the other. These cancel out. We bring down what we didn't mess with. 1 plus 3 is 4. Why is x not alone? It's being multiplied by 2. What's the opposite? Divide by 2. What we do to one side, we do to the other. These cancel out. 4 divided by 2 is 2. The answer is 2 from that big, tough looking thing. Alright? Oh, this is ugly. It's got x's on both sides. What do we do? Well, we can get rid of that radical and it'll be less ugly, right? How do we get rid of a radical? By doing the opposite. What's the opposite of square root? Squared. What we do to one side, we do to the other. It frees it, so it's x plus 2 equals x squared. We have an x squared, an x, and a number. That's a quadratic equation. We just got to get them all on the same side. So I'm going to do minus x and minus 2. So all of that's gone now, so it's 0, and now I can factor it to get the answers. Put my x's there. What can I multiply together to get 2, but added or subtracted is 1? Well, the only factors of 2 are 2 and 1. The bigger number gets the sign of the middle term. Then you think, what does this sign need to be for that to be a -2? It needs to be a positive. So my answers are, my solutions are the opposite signs of this. My solutions are 2 and -1. Now, doing this can sometimes generate extra solutions that aren't true. So when you get back to here, you need to put the numbers back in and make sure it makes a true statement. So my original problem was square root of x plus 2 equals x, before I did any squaring anything. So I need to put them back in and make sure it's true. Well, let's try the 2. Square root of 2 plus 2 equals 2. Square root of 4 equals 2. That's pretty good. That seems right. Square root of 4, 2 equals 2. That one's okay. Let's try negative 1. Square root of negative 1 plus 2 equals negative 1. Negative 1 plus 2 is 1. The square root of 1 equals negative 1. We'll put little question marks here. Square root of 1 is 1, and it does not equal negative 1. So that is not a solution. That's the only one. So if you have x's on both sides, watch out for fake answers. You have to put it back in and check. Another way, well, I won't go into that. Okay, so how about this one? Let's do it. Why is x not alone? Well, it's got a radical sine of plus 13. So we're going to start from the outside in. What's the opposite of plus 13? Minus 13. What I do to one side, I do to the other. Those cancel out. I bring down what I didn't mess with. Uh-oh. Can a square root equal a negative number? No. Remember? Go back here. You cannot get negative 4 unless it's positive 2 and negative 2, and they are not the same. I'd much rather have $2 than owe you $2. So you cannot take the square root of a negative number. So this is no solution, which is always my favorite. I feel like I'm getting out of something, that it's great. So remember, we have 2 big rules in math. I know you think there's more, but there's really only 2 biggies. You cannot take the square root of a negative number, and the other one is that you can't divide by 0. Everything else is negotiable. All right, how about this one? X plus 2 equals x. That was my checking. There was another problem, I didn't do it, but yes, that one worked, that one didn't. And this would have been more proper for me to put little question marks till I got to the end. Question marks and then not. Alright, so that's what I want you to know from 12.3. Most of this is pretty important, but it's easy. You can do it, I know you can. Math is great. See you next time.